All right, so we're doing composite functions. And really, if I have a function f and g, and if I ask you to graph the composite functions, if I ask you to graph f composed of g of x, it's probably easiest to maybe determine what is a valid domain, and then algebraically find the expression for the f of g of x, and then graph that function if you know it. Alternatively, what could you do if you're asked to graph the function f of g of x? Well, you could create a table of values. Now, what x values it would use, I have no idea. Maybe -2, -1, 0, 1, 2, 3, 4, 5, etc., etc. And then you would play this game in which what we're going to do. We're only going to do it for various arrangements of functions, but you could create a table of values for any given x and graph the f of g of x, or even the g of f of x, or the f composed of f of x. So, allow me to get started. We're going to calculate the f of g of x. Now, remember, when my input is 2, what is my function g? What is the g of 2, I ask myself? Now, the absolute value function is f of x. The purple function is g of x. So what is the g of 2? I look for my value of 2, and I ask, well, what is the value of g at that point, my y value on g? And that would be 0. And I would try to use this notation as much as I can. So I'm just going to evaluate the inner brackets. The g of 2 is 0. Now, if I go to my function f and ask, when the input is 0, so my input is typically x, what is the value of f? And here it's 1. My y value is 1. What is the g of f of 0? So the first thing I'm going to do is I'm going to calculate the f of 0. Now the f of 0, well, the f of 0 on my function f, when my input is 0, the f of 0 is equal to 1. Now I go to when x is equal to, what is the g of 1? When my input is 1 on my function g, what is my output? My output is -1. So this means that the g of f of 0 is equal to -1. So if you were to graph the g of f of x, for example, what points does it have? I have no idea, but now it has at least one of them. So if you wanted to draw it out, you might have to do this process over and over again. The f composed of g of -4. So the f composed of g of -4, I'm going to write this as the f of g of -4. Well, the g of -4, now the g is the line. But when my input is -4, my output is -6. So the f of -6. Now, when I go to -6, now unfortunately, it's not defined on my graph. I could take a guess, but I'm going to leave this as undefined because I did not give you the equation of the functions. Now, what's really quite interesting, I think anyways, is that we don't have to be hampered by doing the f composed of g. We could actually do the f of x. That is, we can do the f of x, right? So maybe I'm going to erase that and maybe do the f composed of f of 2. Well, the f composed of f of 2 is equal to the f of 2. So it's really having an input being plugged into the function, and then the function being applied twice. So the f of 2, well, I'm going to calculate in the brackets, the f of 2 has a value of 3. And the f of 3, the value of my function f when my input is 3, is going to be